Functions are a type of relation where there's exactly one output for every input. For every independent variable x, there's exactly one dependent variable y. A function can be written in many forms such as sets, diagram or mapping, a table of values, equations, and graphs. Note that a function is always a relation, but a relation is not always a function. Let us try to identify which of these is a function. We have set A, which is equal to 1, 6 and 2, 7, and set B, which is equal to 1, 5 and 1, 8. Set A is an example of a function because there's only one y value for each x value. In this case, 1 is only paired to 6 and 2 is paired to 7. There are no other values that can be paired with 1 or 2 in this set. In the other case, set B, it is not a function since the x value of 1 had two outputs in y which are 5 and 8. This is a violation of the definition which says exactly one output for every input. Therefore, it is not a function. Now let us move on to diagram or mapping. Is this a function? Yes, it is a function since the diagram shown above, each x value has its own unique output. In this case, 10 is paired with 15, 20 is paired with 45, 30 has the output of 25, and 40 has the output of 35. This diagram is another way to show a function. Now what about this example? As we can see, the x input of 2 has two outputs which are 20 and 40. Because of this, the diagram above is not a function. How about the table of values for the xy chart? Can you say that this is a function? Yes, because again, we can identify and conclude that the x values have only one specific y value. An easier way to understand it is if we can see a repeated x value in the left column. Then it usually indicates that it is not a function. What about this case? Here we can see that the x value of 3 has multiple y outputs which are 1, 2, 3, 4, and 5. Therefore, we can conclude that it is not a function.
Created using Powtoon.